Welcome to this management science tutorial. This is the second part. In the first part we did do some quality control. In the next one we are going to check some service levels. So we've got a company which has recorded its demand over 10 weeks. So usually you would prefer having at least 30 weeks and preferably 2 years of data, so 100 weeks, 104 weeks. Okay, purpose is to introduce you to two fundamental statistics. One is the expectation and the other one is the variance. In particular we take the estimates of them, so the sample mean and the sample variance. And we would like to answer a service level question to say how much stock should we have to fulfill the demand in 95% of the cases. Okay, let's quickly insert this data. So now your num part is an advantage. So we have the week 1, 2, and immediately we can drag this to 10. So 10 values shouldn't take us more than 10 seconds. The demand. We have got 2,900, 5,400, 3,100, 4,700, 3,800. Gosh, I'm already lost. 4,300, 6,800, 2,900, 3,600 and 4,500. Let's quickly check what is the total of that. Okay, that's 42,000. So we do already see the average demand is 4,200 because the number of weeks is 10. And obviously 42,000 divided by 10 is 4,200. Good. We could have saved this division by actually just using the average function. So that's nothing else than the average and sample mean are the same in this case. So there's a function as well. If you don't know the function, like let's say we want to have the variance and we don't really know what it is called, so we just press here, look for variance, find a lot of different variances. This one looks very promising, also it's old, for 2007, so maybe there's a new one. Okay, that looks better. Okay, we can use always the selection and have the variance. Then we can easily get the standard deviation, which is nothing else than the square root. Again, if you don't know the function, just look for square root in this box, and you can find it there as well. Square root of this. Obviously there should be a direct function as well. Let's just see whether we find that. Standard deviation. Again, there is one. Let's get the standard deviation directly from the data, and it confirms our previous function. Good. We have a very strong assumption in here that this data is normally distributed. Also, we could visually see whether this is really the case. It does not look like that in this form. So we actually would have to create the histogram as we did in the in lab 6 to actually see whether it has the shape of a normal distribution, the bell shape. However, since we're assuming it's normally distributed, we can immediately make some statements. So knowing the sample mean is 4200, so if it's a normal distribution, if it has the bell shape, then 50% of this data should be less than the sample mean, and 50% should be more than 4200. With the standard deviation, we can go even one step further. We can go even one step further and say 84% are going to be less than 5,431. But if we have the 95% service level, we need to find actually how many standard deviations shall we add to the expectation. So how do we do that? Well, we know it's the normal distribution, so let's look for a function which has to do with the normal distribution. Normal distribution. Let's see what we find. So there are a couple of functions. So we could immediately go to any of this one this norm inverse function. Use that. Say, okay, what is the probability which we want? We want 95%. What is the mean? Well, the sample mean is 4200. What is our standard deviation? 1232, and immediately we get the quantity of 6226. So that means, let's say if we have 100 weeks, and this is really representative of the 100 weeks. Obviously it's too small, this data sample, but let's assume it is. Then 6,226 units would fulfill the demand for 95 weeks on average. So it's quite useful. We could have used other function as well and gone over the standard normal distribution to achieve the same figure. I hope you enjoyed this tutorial, and I'm going to look forward to seeing you for the next one.